We are looking at chapter 5 of class 10th. This is arithmetic progressions. So what it means is we'll deal with the arithmetic numbers and we'll deal with the progressions, means something which is progressing, these numbers progressing, and how they are progressing is the main key idea of arithmetic progression. Now there are various things which you observe every day in your social life, in your say colony, in your house, like the sunflower, the honeycomb, the grains of maize cob, the spirals on the pineapple, and even the pine cone. Now each of these shows certain patterns. For example, Reena, she applied for a job and she got selected. So she was being told she will be given 8,000 rupees, and annually means every year she will be given 500, means increment. That means first year she'll get 8,000, then 8,500, and so on and so forth. Then this is a ladder. The ladder, it decreases uniformly from this point to this point by 2 centimeter from bottom to top. That is, the bottom rung, this one is 45 centimeter. So what will be the second one? Just you can decrease 2 centimeter. So that will be 43. And likewise, so the last one, that is the last rung, that is the 8th one, will be 31 centimeter. Again, in saving scheme, the amount becomes 5 by 4 times of itself every 3 years. So if 8,000 is there, just take 5 by 4 of 8 by 4, add it to 8,000, means 8,000 into 5 by 4, just add it to 8,000, that will be after 3 years 10,000. Likewise, after 6 years it will be 12,500. In this similar fashion, if you have a unit square, that is the dimension is unit, the side is 1, side is 2, side is 3. So this will be 1 or 1 square. These are 4 numbers, so 2 square. These are how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. So this will be 3 square. So they are following certain pattern. Again, Shakila did what? Shakila said, I have a money box. My daughter is 1 year old and I'll place 100 rupees. And every year I will add 50. So when her daughter was 100, 1 year, the first 1 year, the money box had 100 rupees. Then again on the second year, Shakila again placed 50 rupees or dropped 50 rupees in the money box. So it became 150. And likewise, we'll see a question about this in a short while. Again, a pair of rabbits, they are too young to produce in their first month. So in the first month, they will not produce. In the second month and every subsequent month, they produce a new pair. They produce a new pair. And each new pair of rabbits produce a new pair in the second month. And in every subsequent month, this happens like this. This one, this one. This one, this one. Right? So assuming no rabbit dies, the number of pairs at the start of the first, second, and like this, these are 6th, 1, 2, 3, 4, 5, 6. So there will be 8 pair of rabbits at the end of 6th month. So we have seen a pattern, and what we have seen here is there is a fixed number which is being added to a number so that the second number can be obtained. Again, that only fixed number which has been added here is added to this number so that the third number can be obtained. So if you are discussing the n consecutive terms, so is there any point or is there any way you can generalize this situation? Yes, we can. We'll see some more examples. We just consider these list of numbers. So this is 1, 2, 3, 4. And if you see here, if you take a difference of 2 minus 1, then 3 minus 2, then 4 minus 3, all will give you 1. So each term is 1 more than the preceding term. Again here, each term is 30 less than the preceding term. Here also, each term is 1 more. Each term is equal, means 3 minus 3, this one, and 3 minus 3, and this one, 3 minus 3, it gives you 0. So you have a common difference. You have a common difference 1, you have a common difference 30 in each numbers. And they are following a pattern and they are differing by an equal number. Similarly for this case, this kind of list where successive terms are obtained by adding a fixed number to the previous or preceding number is known as arithmetic progression. Let us generalize and formalize the definition. An arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. And this fixed difference, which you saw, 3 minus 3, 0, 3 minus 3, 0, this 0 is a common difference of AP. And please remember this, as I showed here purposefully, that the common difference can be 0, it can be positive, and it can be even negative. So if we form a AP from A1 to AN, so A2 minus A1 will be equal to A3 minus A2, and the last term, say this one will be what? AN minus 1. So AN minus AN minus AN minus 1. All this will be equal to D, that is the common difference. So the school, if you are standing in a queue in a morning assembly, the height will form an AP like this. Then the temperature you record a week in the month of January in a city, if they are arranged in ascending order, they may form an AP. The balance money after paying 5% of total loan on 1000, like this forms an AP. Again, the cash price from class 1 to 12, 200 if it starts, if you add 50 rupees, 200, 250, it goes up till 750, the person or the student who have got the highest mark. The total saving after every month for 10 months when rupees 50 are saved. So 50, add 50 again, you go up to 500. So what is happening? You started with a term, you added a common difference, means a certain term. Then again you added A plus D, means previous one you added a D. So this is A plus D, A plus 2D, A plus 3D, and the last one will be A plus N minus 1 into D, right? So this is the general form of a AP. So you can have a finite AP. If you see dot dot dot, then it will be an infinite AP. If you see only few numbers without any dot dot dot, means those numbers are precise given to you, that is called the finite AP. So this is infinite, this is finite AP. Now the first term will be represented by A. This will be the first term. The difference, common difference, 9 minus 6, which is in this case is 3, is the common difference. So A is 6 here, D is 3. A and D are very important because we are going to use in the problems. So in this case, A is minus 7, D is what? Minus 9 minus of minus 7. So minus 9 plus 7, that will give you minus 2. So minus 2 is the common difference. All these have A and D. I hope you understood this. D is the common difference of this term with this term, or this term with this term, because all these differences are common. Now this one, take A2 minus A1, take A3 minus A2, take A4 minus A3, all will give you 3. And in this case, 3 minus 6, 0 minus 3 minus 0, all will give you minus 3. So the common difference can be positive, it can be negative, it can also be 0. So let us generalize it. The common difference is nothing but the previous minus the next, any general term will give you a common difference. Either it can be A2 minus A1, A3 minus A2, A4 minus A3, and so on and so forth. Now this number, just take this example. 1 minus 1 is 0, 2 minus 1 is 1, 3 minus 2 is 1, and 5 minus 3 is 2. So 0, 1, 1, 2. There is no common difference. The differences are not common. So it is not in AP. This is actually a Fibonacci series. It is not in a AP. Let us see some certain examples so that you can understand more. This is an AP. Write the first term A. 3 by 2 is A, and the common difference. So 1 by 2 minus 3 by 2. That will give you minus 1. Even if you do minus half, it will give you again minus 1. Any two difference, just take the next term with the previous term difference, you will get a D. Again, which of the following list of numbers does not form an AP? So what we'll do, we'll try to find out the difference. So 10 minus 4, 16 minus 10, and 22 minus 16. It gives you 6. So there is a common difference. So it is an AP. And if you have to find out the next two terms, so 22 because we have found out 6 as the common difference. So you just have to add 6 here, and once you get 28, again add 6. So the second the two terms will be 28 and 34. You just have to add the common difference. Again in this minus 1 minus 1 minus 3 minus of minus 1, it will give you minus 2 minus 2 minus 2 always. So you have a common difference. So this list again is in AP, where common difference is minus 2. Now the last term was what? Minus 5. You just have to add minus 2 to this number, so that you get the next number. Again minus 7, you just have to add minus 2, you get the next number, that is minus 9. How about this? 2 of minus 2, minus 2 of minus 2, you get these values. Sometimes you get 0, sometimes you get 1. So there is no common difference. So this actually is not in AP. How can you get the nth term of an AP? I have already given you a hint that A plus n minus 1 into D is the nth term. How you get it? Now, Reena has applied for a job. She got 8,000 in the first year, and she was being told that she'll get an annual increment of 500 rupees. So first year 8500, first year 8,000, and second year she'll get 8,500 plus 500. Again 8,000 plus 500 plus 500. That means 8,000, then first year, then second year. So what it means is, this can be written as 2 into 500. What is 2 is, what 2 means? 2 can be written as 3 minus 1. So 8,000 plus 3 minus 1 into 500. For the third year, we know that she'll get what? 8,000 means 9,000 she'll get for third year, because 8,000 first year, then 8,500 second year, then 9,000 third year. So in third year, 8,000 plus 3 minus 1 into D, 500, that is 9,000 only. So this is A plus n minus 1, if you have to find out for third year, into D, common difference. So again for fourth year, A plus n minus 1 into D, take 4. 4 minus 1 into D, that will be equal to 9,500. Fifth year, 5 minus 1 into D, that is 10,000. So this is how you get this series, and you got the nth term, or any value in the list you can find out. Maybe in 25th year, what she is going to get? A plus, say 15th year and 25th year. So A plus 15 minus 1 into D. A is 8,000. She started with 8,000. Annual increment is 500. 15 minus 1, because 15th year you have to find out. 15 minus 1 into D. So this is the actual representation. In 25th year, A plus 25 minus 1 into D, that will be this one. That is 20,000 she get. So what we have got is, the first term is A, then A plus D. So A plus D can be written as this. How one can be written? One can be written as 2 minus 1 into 2 minus 1. Then again A3 is what? A2 plus D. So just take A plus D here in this place. So A plus D plus D, A plus 2D. 2 can be written as 3 minus 1 into D. So A plus 3 minus 1 into D. So A3 is A plus 3 minus 1 into D. Again A4 is what? A3 plus D. Take A2 plus D and replace A2 by this one. So you get A plus 4 minus 1 into D. So An will be A plus n minus 1 into D. This is your nth term. Please remember this. This is your nth term. So A plus n minus 1 into D is your nth term. If we have the last term as L, then L will be A plus n minus 1 into D. So that will be last term, if it is a finite series. So let us take an example. We have to find 10th term of this AP. So this is A. 7 minus 2 will be equal to your D, that will be equal to 5, and n equal to 10, because 10th term you have to find out. So A plus 10 minus 1 into D, that is 47. So 10th term will be 47. Again, which term of AP? This is an AP of the AP is minus 81. So this is an AP, and you have to tell which of the term is minus 81. Is any term 0? Give reason for your answer. A is 21, D is 18 minus 21, that is minus 3, and AN, the nth term is given as minus 81. So just use this. AN is equal to A plus n minus 1 into D. AN is minus 81, A is 21, D is minus 3, D is minus 3, and we don't know. So let us solve it for n. You will get n equal to 35. So the 35th term of this AP is minus 81. Now you have to tell, is any term 0? So A plus n minus 1 into D, just place it as 0 and try to find out n. Yes, we got n. So 8th term is 0. Now you have to determine AP whose third term is 5th and 7th term is 9th. So A3 and A7 you have to find out. So A3 is what? A plus 3 minus 1 into D. A7 is A plus 7 minus 1 into D. These are two linear equations. You have to solve it. When you solve it, you get A equal to 3, D equal to 1. That means you have got the series 3 and common difference is 1. So 3, 4, 6, 5, 6, 7. You have to check whether 301 is a term of the list number this. So you have A as 5 and 11 minus 5, that is the common difference. So A is 5 and 11 minus 5 is 6. So D is what the common difference is. AN is A plus n minus 1 into D. 301 is AN a term. You have to place here. We have to find whether this is followed or this is actually inside 301 sometimes when we proceed. So 301 is equal to 5 plus n minus 1 into D, and we have to find in which place this lies, whether it lies or not. So when we solve it, n equal to 151 by 3. So it is not a positive integer and has to be a positive integer, positive z. So 301 is not in this given list. How many two-digit number are divisible by 3? Two-digit means 9 cannot be a two-digit, so we'll start with 12. This is the first number which 3 can divide. Again, 100 is the last, means 100 is a 3-digit, so let us come back or move a step back. So 100, what will be the last number before 100 which 3 can divide? So it is 99. So you have A as 12 now and the last term is what? 99. So this is your last number of your series. The common difference is again 3 because we are dividing by 3. A is 12, D is 3 and last term AN is 99. You have to find number of how many numbers are there or how many number of terms are there. So AN is equal to A plus n minus 1 into D. Just place it and comes to be 30. So there are 32 digit number which are divisible by 3. Find the 11th term from the last term towards the first term of the AP. So this is the first term. This is the difference is 7 minus 10. There are two methods actually. The first method we are discussing. First is A, then D, and then the last term is minus 62. So L is equal to A plus n minus 1 into D. So you can find out n from here. So there are 25 terms, 1 to 25. So you have to check out for that term which is 11th from the last. If you count on your finger, that will be 15th term. If you step back in one step, so the 15th term will be the 11th term from the 25th. So you have to find out A15. So A15 will be A plus 15 minus 1 into D. That will be minus 32. There is another method. What you can do is, you can write this AP in reverse order. So the A will be minus 62 and D is 3 because previously D was minus 3. Here the D will change because you have written in the reverse order. Now you just have to find A11 because you have to start from the back. Now we have already reversed this series. So A11 will be minus 62, 11 minus 2 into 3, that will be minus 32. Right? So the sum of rupees 1000 is invested in 8% at 8% simple interest per year. You have to calculate the interest at the end of each year and do these interest form an AP. If yes, find out the interest at the end of 30 years. Simple interest is what? PRT into 100. So just take P into R into T. Time is 1, rate is 8 and initial amount is 1000 by 100. So this is 80. Second year, 1000 into 8 into 2 by 100, 160. Like this, 250. So you have got 80, 160 and 240. 80, you take difference, the difference is 80. So A is 80, common difference is again 80. So now this is giving you a list which is an AP. So A30 will be what? A plus 30 minus 1 into D. 80 plus 29 into 80, that is 2400. In a flower bed, this is a flower bed. There are 23 rows planted in the first row, 21 in second row, 19 in third row likewise, and 5 in the last row. So this is making an AP 23, 21, 19, like so. A is this 21 minus 23 is minus 2, and the last term AN equal to 5. Let us equate. 5 is equal to 23 plus n minus 1 into minus 2. So n becomes 10. So there are how many rows? 10 rows. There are 10 rows in the flower bed. and we'll try to see the sum of first n natural number. If you recall, the Shakila used to put 100 rupees in her daughter's money box when she was 1 year old. Then every year she adds up 50 rupees. That is, on her second birthday, it became 150. Then on the third birthday, 200. So is there any way you can tell that how much money this money box will contain when her daughter is 21? So the first method is take 100, 150, 200 till 21st or 21 of these and then add it. Now this procedure seems to be quite tedious and time consuming. So is there any shorter method? Let us see. Gauss, famous mathematician, when he was 10 years old, he was given a problem. He was asked that you have to add 1 to 100 positive integers, and he immediately replied the sum is 50, 50, 5050. And can you guess how he actually arrived at this answer? He took it like this: s is equal to 1 plus 2 plus till 100. Then he reversed the numbers. Similarly, the same s will be their sum and this number will be reversed. We start from 100 until 1. He did that. Then he added both the equations, equation number 1 and equation number 2. So s plus s is 2s, 1 plus 100 is 100 plus 1, 2 plus 99 is 99 plus 2, and he saw that all these additions are 101, and he knew that these are how many times? 100 times. So he just multiplied 101 with 100, and because 2 was here, so he divided it with 2, so the answer came as 50-50. So in our discussion, we have seen that the AP was in the form of A plus D, A plus 2D. The sum can be written as A plus D, A plus 2D till A plus n minus 1 into D, which is our nth term. Now just reverse it the way Gauss did. A plus n minus 1 into D, you start with this and reach till A. The sum will remain same. So we have equation 1 and 2. Add these equations. So s plus s, that is 2s. So a plus n minus 1 into d, first one. Then a plus d, a plus n minus 2 into d. As we added, this becomes 2a plus n minus 1 into d, 2a plus n minus 1 into d. How many times? These are n times, right? They are n terms, so it will be n times. So just multiply this term, because they are individual and equal, and they are n times. So just multiply it by n. Now 2 is also here, so divide it by 2. And this exactly is the sum of n, the values or the list, which we call it as AP, arithmetic progression. So the sum of first n terms of an AP is nothing but n by 2, 2a plus n minus 1 into d. So you can also write it as a plus n minus 1 into d. This is what? This is the last term or the nth term. So a plus l also you can write if you are aware of or if you are given the last term. So this is how we got the easy answer to Shakila's problem. So let us solve her problem. She started with a equal to 100 rupees. She added 50 rupees every time, and at the end of 21 years, s will be n by 2, 2a plus n minus 1 into d, and that comes up to 12,600. So on her 21st birthday, Shakila's daughter will have 12,600. So we will write this s as s21, the subscript 21, showing it that the sum is till n equal to 21, or sum of first 21 list or the items in the list, which is we call it as AP. So s sum, a first element, d common difference, and n is the number of n's which the question will ask. Then let us come to the example. So find the sum of first 22 terms of the AP. 8, 3, minus 2, dot dot dot. So a is what? 8. Common difference is 3 minus 8, that is minus 5. and we have to find the sum of first 22 numbers, so n will be 22. Just place in this equation n by 2, 2a plus n minus 1 into d, these are known. The answer would come as 979 negative. If the sum of first 14 numbers or 14 terms of an AP is 1050, its first term is 10, find the 20th term. So the sum of 14 number is given. So we are being provided S14. So S14 would be 1050. This is equal to S14. This will be equal to n by 2, 2a plus n minus 1 into d. In this case, the first term is given as 10. So a will be 10. N is what? 14. And the sum is here. So 14 by 2, 2a plus n minus 1 into d. So d comes up to 10. Now we have to find what? We have to find the 20th term. So a20 will be equal to a plus 20 minus 1 into d. So a is known 10, d we just found out as 10, just place it here. 20 minus 1 is 19d, so the answer would be 200. How many terms of the AP 24 till must be taken so that their sum is 78? Now a is 24, d is 21 minus 24, that is minus 3. The Sn, which is the sum of these numbers, is 78. We need to find out how many numbers add up to 78. So Sn is 78, just place it here. We have to find out n, that will come to some quadratic equation. Just solve it by factorization, n minus 4, n minus 13, and will be 4 and 13. If you see the 4 term and 13 term, they both add to the same number. So this is the answer. Now you have to find the sum of the first 1000 positive integers. First 1000 positive integers, that is, you have to find out s equal to 1 plus 2 till 1000. Now the first term is given as 1, the last term is given as 1000. So you can directly apply Sn equal to, that is s 1000 is equal to n by 2 a plus l. A is 1, l plus 1000. So this comes to 1000 by 2 into 1001, that is equal to this 5,500,000. The Sn of the first these numbers, the question is like this: first n positive integers, so 1 to n. Now the answer will come in the form of n, in terms of n. First term is 1, last term is n. So we'll just directly use Sn is equal to n by 2 a plus l, that is 1 plus n, that is equal to n plus 1 by 2. Now this becomes very important because in later classes also we'll directly use the sum of first n numbers, positive integers or natural numbers. Why? Because this becomes very important, we'll directly use it. So please, you may memorize this. Now find the sum of first 24 terms of the list of numbers whose nth term is given by this. An is given, so let us take a1. You just have to place 1 here. a2, you place 2 here. a3, place 3 here. So 5, 7, 9. So this becomes a list. What is the first term? A, that is 5. Common difference is 7 minus 5, that is 7 minus 5, or 9 minus 7, 11 minus 9, that gives you 2. So common difference is 2. Now you have to find the sum of first 24 terms. So S24 you have to find. S24 will be n by 2, 2a plus n minus 1 into d. So n is 24. 2 into a, that is 2 into 5. n minus 1, 24 minus 1 into d. It gives you 672. Next is the manufacturer of TV sets produce 600 sets in the third year. So A3 is given as 600. And we know we can directly write it as A plus 3 minus 1, that is 2D, equal to 600. Similarly, the seventh year the production is 700. So A7, what is this? A plus 7 minus 1 into D, that is A plus 6D. So A plus 6D is what? 700. So A plus 6D is 700. A plus 2D is 600. Now we have to find various parts. So let us solve this. We can directly solve this. 6D minus 2, that is 4D, will be equal to 100. D will be equal to 25. And A is already given, that is 550. How did we come up? We can place this D in any of these equations, 1 or 2. And you can find out 550. So A and D we have found out using the situation which is given. Now the production in first year, the production in the 10th year, and the total production in the first 7 years. So the A10 will be A plus n minus 1 into D, that is 10 minus 1 into D, you know A and D, 775. S7, that is 7 by 2, because first 7 terms, 7 by 2, 2A plus 7 minus 1 into D, that is 4375. So the total production of TV sets in the first 7 years is 4375. So let us summarize what we have seen up till now. The arithmetic progression, they are nothing but the list of numbers which are obtained by adding constant D or equal D to the preceding number. We call this D as common difference. So if this is A, we add a D. Again A plus D, we add a D. A plus 2D, we add a D. So they differ by a common value which is called the common difference. And any nth term will be given by A plus n minus 1 into D. Then the sum of first n terms of an AP is given by S equal to n by 2, 2A plus n minus 1 into D. If you know the last term, sum will become n by 2 A plus L. A will be the first term, L will be the last term. So if you want to find out this B, and if A, B, C are in AP, you can directly find out B is equal to A plus C by 2. So this is all about the arithmetic progression. Thank you so much. Take care of yourself.